Hey guys, so this is 1.10 transformations of absolute value functions. This is number 1 and 2 from your homework. So we had said in class that y equals the absolute value of x is the original parent function. So this is actually what we graphed in class, the original parent function, when no transformations has been applied yet. So in this case, our h would be 0, and our k would be 0 because we didn't subtract anything from the x and we didn't add anything at the end. And in terms of a would be 1. It wouldn't be 0 because we don't want to multiply 0 by the absolute value of x, otherwise that whole thing will become 0, right? So just like how we graphed it in class, we've actually graphed this like twice in class already. Our vertex is at 0, 0. And because the variable a is positive, I know that my graph is going to open up. So I'm going to start graphing here, 0, 0. Okay, and then if you want, you can certainly make a table of x and y values and pick some x values so you can get an idea of what the graph looks like if you're not sure still. So the absolute value of -2 is 2, the absolute value of -1 is 1, 0, 1, 2, and we have the same graph that we did in class in your notes. It's a V shape that continues to go up and to the right and go up and to the left. Right, and the vertex is at 0, 0. So my y-intercept, it says the y-intercept, think about what that means. The y-intercept is where the graph intersects the y-axis, and that would be at 0, 0. There's only one y-intercept. And then similarly, the x-intercept, or x-intercepts, sometimes you might have two, is where the graph intersects the x-axis. So that's identifying key parts of the graph that you kind of did in your last quiz and with linear functions. But now instead of a line, we have a V shape. But we can still identify where the graph intersects the x-axis. So in this case, it's still just 0, 0. The graph touches the x-axis and at the y-axis at exactly the same point in this particular case. All right, so looking at this graph that we graphed already in class, let's look at the domain and range. That's something that we can identify. So I can't box in the left and I can't box in the right. So I can't put a limit on how small the x-coordinates of all of those points can be. And there's no limit on how large the x-coordinates of all of those points can be. So that my domain, we're going to say it goes from -infinity to infinity in interval notation, and then parentheses because we're not including either, and then the range. So if you notice, when we look at the range, we look at the y values and we start from the bottom and we work our way up. So it looks like my graph starts when y is 0 and then it continues to go up forever. So my range is going to go from 0 to infinity, including 0, but not including infinity. Now the only thing we haven't really looked at is the slope of the graph on the left side and the slope of the graph on the right side. So you know that in an absolute value graph, it's a V shape, and the left and the right side are symmetric. So if we kind of just look at the right side and we look at the slope, it looks like I'm going up 1, right 1, up 1, right 1 every time. So my slope on the right side is +1 over 1. And the slope on the left side, if we read our graph from left to right, it looks like every point I'm going down 1, right 1, down 1, right 1. So my slope on the left is -1. So I want you to notice that the slope of the left side and the right side are opposites, right? One side's going up, one side's going down. That's how you form that V. I also want you to notice that the slope of the right side happens to be A. And let's see if that's true in the other example. So let's look at number 2. Okay, and then I'm going to put the standard y equals, or f of x equals A times the absolute value of x minus h plus k on top. Okay, so in this case our scale factor that we're going to multiply by A is 2/3, and then A is negative, so negative 2/3. And H is 1. Remember, it's not -1 because what's applied to the x is counterintuitive. So if it says -1, we're actually going to move to the right one space. Okay, and then k is at 2. So from my original graph, and you can sketch out the original graph if you want to see it on top of each other. So this is my original graph, y equals the absolute value of x. My vertex, which was originally at 0, 0, now moves to the right one space and up 2 spaces. And it is right here. Okay, so this point moved to the right 1 and up 2, and now it's right here. So my vertex is now at 1, 2. Okay, and then remember what we said that negative does. The negative, if A is negative, it kind of flips my graph across the x-axis. So now my V shape should open down. I should have something that looks like this. Right? And then in terms of what my graph is going to look like, remember we had said that the slope of the graph on the right side is actually the same as A. So that's actually going to be a rule for absolute value functions. That's always going to be the case. So we're going to, on the right side, my slope is going to be negative 2/3. So I'm going to go down 2 to the right 3. And we had also said in class that if my scale factor, if I'm multiplying it by 2/3, it's between 0 and 1, it should compress my graph vertically, right? It should make it shorter and fatter, and so we should see that in our graph. So down 2/3, down 2/3, and here is the right side of my graph. And then on the left side, note the left side and the right side should be symmetric. Okay, so it's gonna be the opposite, so that the V can go down this way as well. And here is my new function. F of x equals negative 2/3 times the absolute value of x minus 1 plus 2. And then if we try to identify the x and y intercepts, looks like I have an x-intercept at 4, 0 and negative 2, 0. Remember, x and y intercepts are points, so give me an ordered pair. And then the y-intercept The y-intercept is a little trickier because it's hard to tell. It's right here, but it's not exactly right here, but not exactly at a specific integer where I can see clearly. Okay, so we're gonna have to do some math to figure out what the y-intercept is. Let me do it in pink. So I know that at least for the y-intercept, I know that my x-coordinate is 0 something. So all I have to do is figure out what if x was 0, what would y be? And I can do some substitution. So I'm going to write y equals, so f of x is the same as y, and I'm going to substitute 0 in for x and figure out what y is exactly. So the absolute value of -1 is 1 times -2/3 is +2/3. Still -2/3. And then add that to 2, I need a common denominator. So let's rewrite the 2 as 6/3. And then that would give me y as 4/3. Which is 1 1/3. Okay, 1 1/3. So that is your y-intercept. And we're just practicing on finding x and y-intercepts throughout this process because that's something that you will continue to do throughout the course of this year. And then the domain on the left and the right side still cannot put a limit on it, so we're going to say -∞ to infinity. And then for the range, it keeps going down. So for my y values, it goes from -∞ all the way up to +2. That is as high as my graph can reach. And you can see that my graph did get compressed. It got shorter and wider. So for each one of these problems, what I'd like you guys to do is identify what A, H, and K is. That's the most important thing that I want you to take away from today's lesson. Be able to identify what A, H, and K is. HK is always your vertex. Be able to identify the vertex. Identify whether your graph is going to open up or down. And then use the vertex to help you make your graph. So once you know the vertex, you know where the middle of that V is. And then to figure out how wide your V is going to be, you can use the A value, which happens to be the slope of the right side. And then once you have one side, then you know that the other side is going to be symmetric and you can draw the other side.